This is the Tachyscope laser project. A 360-degree mechanical oscilloscope. Here you see a time-lapse image of an audio signal. The red lines are the result of a laser beam reflecting off a mirror attached to a moving coil, aka galvanometer, while spinning on a turntable. Below the turntable, you can see the 4 UV201A vacuum tubes. The tubes are 100 plus years old and still working. Here you can see a slowed down example. The diameter of the turntable is 12 inches, and the height of the target display is 5 inches. The table rotates counterclockwise at a variable speed to create the time axis of the oscilloscope. At the top of this image you see the display target lit up in red by the laser. Below that, the galvanometer or stepper motor. Attached to the stepper drive shaft is the mirror. Below the turntable in black you see the 4 amplifier tubes. To the far left of the image is the Helium Neon laser. Just ahead of the laser is the Decatron display tube, and finally the front control panel, still being completed. In this graphic I show the laser beam path to the target display. The beam leaves the laser tube, does a 90-degree turn downwards, to a second mirror that sends the beam upwards through the center of the turntable drive shaft, hits the mirror on the galvanometer, which in turn creates the amplitude axis of the tachyscope. I could have used a solid-state laser, aka laser pointer, rather than the Helium Neon laser. I wanted the old-school light effect from the neon glow of the laser tube. This diagram shows the tube amplifier connected to the stepper motor, in effect turning the stepper motor into a crude galvanometer. Power and control to the stepper are fed via a multi-pole slip ring. Side view of the tachyscope. Overall view of the lighting. Laser surrounded by the blue flicker candle LEDs. Above the laser, the Decatron spinning. My left hand is changing switches. Also notice the green and amber lights doing a chase pattern and the Nixie tube counting up down. The spare panel on the right is for the next phase of this project. I will be adding an 8 LED POV character display. Here are a few chase patterns on the Decatron tube. This pattern is called Yo-Yo. This pattern continuous counter, clockwise spin. This pattern continuous clockwise, fast spin. This one double spin and return. Last one pendulum. Here, I'm sliding the switch knob up or down to select which pattern to display on the Decatron tube. There are 8 options on the slide switch. Notice, the knob contact glows green on whichever option I land on, in this case number 7. It will stay green for a few seconds. The number is reflected on the Nixie tube. After a short delay, the up-down standby mode chase will begin. When the slider knob is moved to a new contact, that value will be displayed on the Decatron and Nixie displays. Construction photos. Wooden cabinet, power switch. Cabinet ready for staining. Mounting the drive support and slip ring assembly. Some blue EL wire and glass tubing. Location of laser tube. Making the brass supports. Wires and copper tube for Decatron. 12-volt power supply location. Laser beam making its way from the laser tube to the center of the cabinet. Tube amplifier. Donor battery radio set. Bakelite 4-pin sockets. Box of old tubes. Fitting the bases. This tube has a burnt filament, Keeping the brass base, removing the brass base from bad tube. This tube is electronically good. Remove Bakelite base and replace with brass one. Final result, good tube with brass base. Prototyping the audio amplifier circuit. The galvanometer. Trial and error testing the stepper with laser pointer. Stepper from old printer. Making the brass control plated, mask for etching. Laser printed onto photo paper. With iron will transfer toner to plate. Toner now transferred. Etched and cleaned up. Next up slide switch brass plate. Confirming proper temperature. Transfer of toner complete. A few minutes in the etchant. Etched and ready for drilling. Contacts installed, inked and clear lacquered. Final look and testing. Making the logic PCB. Laser printed and glued to PCB. Populated with components. Added IC chips. Backside showing point-to-point wiring. Close-up of Nixie tube connections. Making the slip rings. Used casing of C-cell battery. Used contacts from 4-pole relay. Cut rings into battery casing. Adjusting height of contacts. Final look.